Hi, good morning, everyone. Today we are going to see the lecture series 2 in our analog electronic circuit subject. So today the topic is inductor and capacitor. So what is inductor? So inductor usually it won't allows the changes in the current, instantaneous changes in the current. So in detail, if you see inductor in detail, the inductor stores the energy in magnetic field in electric current flowing through it. You just look at the circuit where there is one current source which is represented by the letter I, and it is flowing in one direction. In the another side, it has some um, that is a one magnetic field that is a it's when there is a flow in the conductor, it produces the magnetic field. So this is called the inductor. So it stores the energy in the form of magnetic field. When the current flowing through the inductor, it stores the energy in the form of magnetic field. And both the inductor and as well as capacitor, which is used for storing the energy only. But in inductor, that stores the energy in one form, and when you go for the capacitor, that stores the energy in the another form. So these are all the types of inductors. That is a air core inductor, iron core inductor, ferrite core inductor, variable core inductor. These inductors we can see in many gadgets. That is PCB boards, PCB board. So according to the purpose and the usage and the requirement, any one type of the inductor can be used in the PCB board or circuit diagram. And you can see the PCB, the actual inductor which is available on the PCB board is given here. That's a first one is copper wire wrapped around a ring. Then second thing, copper wire wrapped around a cylinder and a casing to shield the magnetic field and to prevent from interference with other components. There is a shield is given in the shield is wrapped by the casing, right? So these are all the inductors you can see in the printed circuit board. And what is the property inductor? So the inductor properties, it hates the instantaneous changes in current that I already told you. That is, it passes it passes the DC and decreases the frequency, and it won't allow the AC component. The example is here in the right side of the slide, you can see if XL is an inductive reactance. What is inductive reactance means? In some frequency, some of the cases, the inductance will have a property of reactive property. That means then it will react. That means it will oppose. So XL is nothing but of, according to the inductor, the inductive reactance is XL. The XL is nothing but of 2 pi FL. So where here F is a frequency and L is a inductance. So I told you the AC will not be allowed through the inductor, only the DC will be allowed. The reason behind this is here you see the this calculation. If inductor, if the frequency value is 60 hertz and inductor is 2 Henry, so Henry is nothing but the unit of inductor. So if you calculate the value, the XL value will be 753 ohm. That means that if you give the 60 hertz frequency for 2 Henry inductor, that will produce the 753 ohm resistance. That is a reactance. So automatically that means that the AC will not be allowed to the through the inductor. But in the same case, if you consider F instead of F 60 hertz, instead of 60 hertz, if you put the value of 0, what happens? XL equal to 2 pi FL. So F is 0, and whatever may be the L, the term XL will become 0. That means that DC component that does not have any frequency term, so that means that the DC frequency component of DC is 0. So F equal to 0, so XL will be 0. That means that the in the DC cases, the direct current cases, the inductor will allow the current. So this is the property of inductor. And comes to the next thing, that's a capacitor. So I told you already, both capacitor and inductor, which is used to store the energy. but in a different way. That inductor will have a different way and capacitor will have a different methods. Capacitor usually it won't allow the instantaneous changes in voltage. So here, capacitor stores the energy in the electric field and when voltage applied across it. That means that the capacitor is actually nothing but of a, there is a two parallel plate. In the two parallel plate in between there is a dielectric material. When we are applying the voltage across it, the electric field, in case of inductor, that is a magnetic field. Here electric field produced, so this stores the energy in the form of electric field. So that is shown in this circuit diagram where V naught is a some voltage, input voltage, and R is a resistance, and C is a capacitor. Whenever we draw the capacitor, the two lines must be equal. That must be symmetrical. Usually we will do the mistake for voltage source and the capacitor. Voltage source, the positive line must be larger and the negative line must be smaller. But in the capacitor, both the lines must be equal in size. So here, when we are applying the voltage and there is a one line is there, after the voltage term, there is a one like switch like one symbol is there. There is nothing but of when you on the switch, the voltage will be the voltage will be on and the current flowing will be takes place. Automatically that it will store, it will create the electric field. So that is represented as a VC. So these are all the types of capacitors. So ceramic capacitor and electrolytic capacitor, variable capacitor, and trimmer capacitor. So based on our need and requirement and application, we can use either one of the capacitors accordingly. And we usually have a doubt between capacitor and battery, because we discussed just now the capacitor is to store the energy. So instead of battery, we can use the capacitor in many applications, right? But the actual difference between these two means, what does that means? The battery it have a more storage and slow charging and discharging, but in the case of capacitor, it is a less storage, fast charging and fast discharging. So due to this fast charging and discharging and less storage, it is not used for our commercial purpose like our daily life applications like mobile phone batteries and any other LED batteries. So we are not using this capacitor, only we are using the batteries. So this is the difference between battery and capacitor. And this is the, you can see this is the capacitors on the PCB board. So there are various types are there that we discussed in the previous slide. So one among the type of capacitor can be used in the PCB board. And here the capacitor operation is given clearly in this slide. First image you just see, there is a battery and capacitor is there and resistor is there. Finally, LED is there. So battery is disconnected from the other terms. So there is no current flow. Okay, there is no input will be given. So the LED is not glowing. And again, if you make the charge, right, if you given the charge for some times, so the capacitor will become charging. And even if you disconnecting the charger, if you can disconnect the battery, because of the charge available in the capacitor, that will operate the that will function the LED. So this is the simple example which shows the capacitor operation. So thanks for watching the video, and by the next session we will see the next topic in our analog electronic circuits lecture series. Thank you.